Hi, my name is Khatri. I'm an interventional cardiologist at Weill Cornell Medical Center in New York City. I want to talk to you today about MicroRx. It's a rapid exchange guidewire control and support system. I want to talk to you about how it works in real-world practice, and I'll give you a case example of where I've used it successfully. Everyone is familiar with complexity of PCI, particularly with advanced patient age as well as patient comorbidities. And the challenge is that workhorse wires can stall out due to tortuosity and or a tight stenosis. As we navigate a workhorse wire through the coronary tree, forward progress can stall because of both calcium as well as tortuosity due to inadequate wire control or inadequate guide support. Once the guide wire is to the lesion itself, there can be challenges crossing the lesion because of calcium and tortuosity again. This can be overcome with over-the-wire systems or escalation to more slippery wires or stiffer wires, but ultimately these maneuvers can lead to complications. And what we really want to do is maintain rapid exchange for efficiency and workhorse wire for safety, if at all possible. And this is where MicroRx comes into play. So we're all familiar with the potential advantages of over-the-wire support systems for our guide wire. This isn't always practical and it isn't always available, and MicroRx allows the operator to have many of the advantages of an over-the-wire system without having to have the inefficiencies of resorting to such. So using MicroRx, the operator can dramatically improve wire support and control through tortuosity and calcium with their workhorse wire. Once their workhorse wire is to the area of stenosis, the MicroRx can dramatically improve the penetration power of the workhorse wire and maintain guide wire torque response and control as you navigate through the lesion. And lastly, once you cross the lesion, MicroRx can actually daughter the area of stenosis, facilitating subsequent therapies such as NC balloons and or stents depending on the scenario. So the first thought that I had in my mind is, how is this different than just using a rapid exchange balloon? And the answer is the construction of the MicroRx. So there's a skeleton backbone to the system that makes it far superior to the deliverability of a rapid exchange balloon. The skeleton backbone improves the pushability of the MicroRx through the lesion, it improves torque response, and it makes the catheter far more flexible than a balloon would be. We're all familiar with how over-the-wire microcatheters can increase the tip load of any given guide wire, and the same is true for MicroRx. So the solid lines represent the behavior of guide wires that are supported with a MicroRx, and the hashed lines are the same wire without support. And as you can see in every example, there's a dramatic increase in the tip load, or the force that the guide wire can apply to the area of stenosis when supported with MicroRx. So these are how the device can both get you to the lesion and then allow the guide wire to actually cross the lesion once you've achieved adequate position. So schematically, the device is 150 centimeters long. The actual microcatheter portion is 15 centimeters. The shaft has marks on it to indicate both 90 centimeter and 100 centimeter exit points for the tip of the microcatheter, as well as the exit point of the rapid exchange portion. So you can keep track of where you are based on these markers in relation to the guiding catheter. What I think is really interesting about the device is the back end. So the back end is designed such that you don't need to give up any position in the event that you determine that you don't have enough guide catheter support. So for example, you have a wire across, your MicroRx is down, and you find that you just don't have enough guide catheter support to complete the procedure and you need an extension. So the device is designed to accept any on-the-shelf extension without having to remove the MicroRx, which is very interesting and very convenient. Let me show you an example of a case that we did here recently. So this is a post-CABG patient who has a vein graft to a very diseased obtuse marginal branch. Now, the challenges with doing vein graft interventions is oftentimes by the time you get down the vein graft, you run out of wire control or wire support, and it's very difficult then to control the wire through these tight lesions. And ultimately, this can require stiff wires or slippery wires to get through these lesions. We did all of this with a Xi'an blue workhorse wire using a MicroRx for support, pre-dilled the lesion after daughtering with a MicroRx with an NC balloon, and then treated the lesion with a paclitaxel drug-coated balloon. So on this fluorosave, you'll see we have a MicroRx down to the distal vein graft, and this was enough to provide support for the Xi'an blue to cross the area stenosis. I feel much better having a Xi'an blue into this distal diseased vessel as opposed to a polymeric wire or a stiff wire. I don't think that this wire is nearly as likely to cause a complication. We daughter the lesion with a MicroRx. This allowed pre-dilatation with an NC balloon, and then ultimately treated with a paclitaxel drug-coated balloon, and then this is the completion angiogram. So a nice, efficient, and safe procedure done with rapid exchange equipment. So in conclusion, I would say that MicroRx is a tool that can be used to dramatically improve the effectiveness of workhorse wires in a 6 French system. It allows expanded reach of workhorse wires, streamlines the crossing of challenging anatomy, and it can potentially facilitate crossing and treatment of lesions once a guide wire is across. Thank you so much for your attention.